So let's finish this up. Here's where we left off. We said we had 2.4 amps here, 1.2 amps here, zero point 0.8 amps here, and 0.6 amps here. All of those would combine together as they flowed through this part, through the battery there. So here's the third rule. The total current going through the battery is the sum of the current in all the branches. So if we had 14 amps coming out of the battery, it might split up and we get 3 amps through one branch, 5 amps through another branch, and 6 amps through a third branch. But then those would all have to combine back up to a total of 14 amps. This one, by the way, here would have the least amount of resistance, and this one would have the most. How do I know that? Because it has the most current, therefore the least resistance. In equation form, we could write like this. The total current is equal to current 1 plus current 2 plus current 3 if there's a third branch, and so on. This, by the way, is known as Kirchhoff's junction rule, and it is basically a conservation of a charge applied to circuits here. Think about this. Let's say we have a toll booth, or this toll booth could be someone checking you to go into a Reds game or something. So this would just be one resistor. If we put several checks in a row, this would be like series. This would make it even harder to get into the stadium or through the toll road. But if instead we added resistors, those are our toll booths, in parallel, this would actually increase the flow compared to this first one here. So it seems counterintuitive, but as you add resistors into a circuit, as long as they're added in parallel to the first one, you will always make it overall easier. In other words, you will drop the resistance of that circuit. Another good analogy is if this is a checkout lane at Target or wherever, if they open up more checkout lanes, even if these are slow old employees, overall the flow of the store will go faster. In other words, there is less resistance to getting out of the store. So this is the fourth and last rule of parallel circuits. Resistance of the circuit drops with each branch added. And therefore, the current coming out of the battery actually will go up. The total resistance is going to be less than the smallest resistor because we can just always pretend that we started with that resistor. And the equation looks like this. 1 over the total resistance is equal to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. So let me give you a few examples here. If we have a 4 ohm and 4 ohm in parallel, that's twice as easy to get through if there was just one. So it's only 2 ohms is the equivalent resistance. A 6 and 6 in parallel would be the same thing as a 3, and a 12 and 12 in parallel would be the same thing as a 6 there. Let me give you an example of how to use the equation here. So let's say, here it is, 1 over the total resistance, or you can say equivalent, is equal to 1 over resistor 1 plus 1 over resistor 2. Well, in this case, 1 over the total resistance would equal 1 over resistor 4, or resistor of 4 ohms, plus 1 over of another resistor of 4 ohms. So 1 over 4 plus 1 over 4. That would give you 2 over 4, which simplifies down to 1/2. But be careful, the total resistance is not 1/2, that's 1 over the total resistance. So to get the total resistance, we have to flip our last answer there, and the total resistance would be equal to 2. If you have 3 equal resistors in parallel, it's only 1/3 is the equivalent resistance. So 3 6 ohms in parallel is 3 times as easy to get through as just one, so it'd only be 2 ohms would be the total resistance. So 3 9 ohms would only be 3 ohms as the total resistance, and 3 12 ohm resistors would only be 4 ohms would be the equivalent resistance. Let's finish with an example here. So let's say we have a 12-volt battery. By the way, this little E symbol stands for EMF. It's just another term for voltage. What would be the voltage drop across resistor 1 here? 12 volts. Same thing as resistor 2, 12 volts. Same thing as resistor 3, 12 volts. How do I know that? Because they're all in a parallel circuit with the battery, so they all drop the battery, 12 volts. We can find the current in branch 1 by using Ohm's law. Take that 12 volts, divide it by the resistance. So I equals V divided by R. 12 volts divided by 2 ohms gives you 6 amps. So do 12 volts divided by 3 ohms, that would give you 4 amps. And do 12 volts divided by 6 ohms, that would give you 2 amps here. I'm actually going to need one more video to finish this up. And so we could find the total current by doing 6 amps plus 4 amps plus 2 amps would be a total of 12 amps. So we will finish the very end. It won't be a very long video in the final video here.